Hello and welcome to the Introduction to Physics. These are concept bits by Online Pathshala. So, are you ready? Let us begin. The first and most important question is, what is physics? Physics is simply the study of basic laws of nature and their manifestation in different physical phenomena. The second concept is, what do you mean by unification in physics? As the name suggests, it is the attempt to explain different physical phenomena using common rules or principles. The next important question is, what is reduction in physics? As the name suggests, it is the attempt to understand complex systems in terms of its constituent parts. What is the scope of physics? What does the study of physics cover? Well, the physics covers tremendous range of physical quantities all the way from minute atomic to the huge unmeasurable astronomical phenomena. How are physics and technology related to each other? Sometimes technology results in a new domain in physics, whereas at other times advances in physics generates new technology. Fundamental to the study of physics is the study of forces. Physicists have come to believe that there are four fundamental forces in nature. What are these four fundamental forces? The four fundamental forces are gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. And it is understood that all the other types of forces can be derived from these four fundamental forces. Let us quickly look at the key concepts behind these four fundamental forces. What is the gravitational force? Gravitational force is the mutual force of attraction between two objects, and it is proportional to the masses of these two objects. The most important part about the gravitational force is the fact that it is a universal force, which means that every object in this universe has or experiences a gravitational force due to every other object in this universe. The second type of force, that is the electromagnetic force, is an attractive or repulsive force between two charged particles. And it is important to note that it is significantly stronger than the gravitational force. The third type of force, known as the strong nuclear force, is an attractive force that binds the protons and the neutrons in the nucleus. It keeps the nucleus stable, which would otherwise fall apart due to the force of repulsion between protons, which are all positively charged. What is a weak nuclear force? It appears only in certain nuclear processes. An example is the beta decay of a nucleus. So, having looked at the forces in very brief, let us quickly summarize how these four forces relate to each other. The table here summarizes all the four forces. Now, when we look at the relative strength, which is given in the second column over here, the relative strength shows that the gravitational force is the weakest force experienced by objects, whereas the strong nuclear force is the strongest force. When we look at the range of these fundamental forces, that is the range over which these forces are applicable, gravitational force applies up till an infinite distance. Weak nuclear forces operates only upon very short distances, which could be known as subnuclear, and they are in the range of 10 to the power minus 16 meter. The electromagnetic force also applies at a range of infinite distances, but it's quite strong. whereas the strong nuclear forces operates upon very short nuclear distances and a typical range is around 10 to the power minus 15 meter. Now, the objects amongst which this force operates, gravitational force operates among all objects in the universe. The weak nuclear force is mainly experienced between electrons and neutrons. The electromagnetic forces is experienced amongst all the charged particles. And the strong nuclear force is operated among or it's observed at the level of nucleons and heavier elementary particles. Now, another important concept in physics is that of conserved quantities. As the name suggests, conserved quantities are physical quantities that remain constant with time. They do not change. The most important example of a conserved quantity that you might well be aware of is energy. Energy is a perfect example of a conserved quantity, as you might have learned the law of conservation of energy, which states that energy can neither be created nor be destroyed. It can only be converted from one form to another. So the total energy is always constant. So that was all the concept bits in the first chapter. And good luck